I am going to try to work one of these questions out. Josh wanted me to model how to answer everything, so I'm going to try to do this for you as best as I can. So here we go. We're going to try AP Stats Quiz B, the one about the Olympic Games and the number of women that participated in it. So first thing I have to do, I already kind of got a little bit of it written out already, is I need to identify my parameter. And this piece right here, this guy right here, this is my parameter. And I have to always say what the parameter is, because that's what P stands for. Okay, and so when I read the question, it says the IOC believed that the female participation in the 2004 Summer Olympic Games was 42%. So there is my parameter, 0.42. And they said broadcasting and clothing companies want to change their advertising and marketing strategies if the female participation increases in the next games. And so they did a pre-Olympic exhibition. And so over here, this is their sample section right here. This is the sample. So out of 454 athletes at this Olympic exhibition, 202 were female. And so this is where I end up getting my p-hat, 0.445. And so now I'm going to establish my alternative hypothesis. And so they want to say, is a strong evidence that the participation rate may increase. And so when I write my alternative, I want to say, is it bigger than 42%? Okay, and so the procedure I'm using, still part of the stating process, is the name of the test. So I'm going to use what's called a one proportion z-test. Okay, and so this is all part of the state. Every bit of this. This is all state. It's info I'm going to use there. All right, the next part is the planning process. So when I'm planning, that's when I address the conditions. So I'm going to read up there, did it say simple random sample? And it said in a random sample, it didn't say simple, but I'm going to kind of assume that it was. So I'm going to say it was stated. And then is the population at least 10 times sample size? So I'm going to include that number there. So I'm going to say there are at least 4,540 athletes in existence. I'm going to assume as independence, that each athlete is independent of the next athlete. And the last thing I have to do is my normality check. So that's where I use n times p. Now it's the p naught, okay? Is n times p greater than or equal to 10? N times 1 minus p greater than or equal to 10. So I'm actually going to use 454 times 0.42. Is that greater or equal to 10? And 454 times 1 minus 0.42. Is that greater or equal to 10? And so when I look there, I got 190.68, 191, and then 263. Yes, both are greater or equal to 10. So normality has been checked. So approximately normal, I can proceed. The next thing I want to try to do is the actual do part. And so I'm going to set up my z-score. Z is equal to p hat minus p naught. And this is what I'm seeing a lot of us are messing up on. We are putting the wrong p. This is p naught underneath the radical. So remember, if you know p, preferably p naught, use p naught. Okay, my little phrase there. So I'm going to fill in the numbers that you need. So Z is equal to 0.445, the percent of women from the trial, the exhibition, minus P naught, 0.42. And then underneath the radical is my 0.42, 1 minus 0.42, all over 454. Now, I am using my calculator, and I'm going into the calculator menu, and I'm going to enter in everything that's included. So I think the first thing I need to set and do is when I run my test, I'm going to choose under Stat, go to Tests, go to One Prop Z Test, and I'm going to enter in P naught, which would be 0.42, and then X stands for how many successes, if you will. So 202 females out of 454 total participants. And then what I choose as my decision is the same thing as my alternative. So I want to be greater than the null. So I'm going to pick the third option over. And when I go to calculate, I get a z-score of 1.08. And I'm making a stinking sketch because I told you so. So 1.08. And I need to find that dark shaded area, that region. That's my p-value. All right, and I'll get to explain the p-value in a second. But it's the area under the curve to the right of that 1.08, that z-score. And so the calculator gives it to me. It says that my p-value is 0.14. So just knowing your normal curve, there's 14% at or above that z-score. Well, that's not very significant. We want this value to be extremely low because the idea behind a p-value is it's the likelihood of me getting a percent this big due to just random chance, knowing that the null was true. Well, when you do research, you want your p-value to be low. You don't want it due to random chance. You want it due because you want it due to the fact that you want the null hypothesis to be rejected. You want that to be false. So is there much difference between these two numbers? Is it significant enough? And so that's the whole purpose of calculating your p-value. And so it didn't tell us a level of alpha to use, so we're going to use level alpha 0.05. And you're just going to compare. Is your p-value less than alpha? And if it is, then we reject. Well, ours is not. 0.14 is not less than 0.05. So I, in other words, fail to reject. Okay? And so what do you do with that? Well, your conclusion says this. You got to include what type of alpha you're using. Using an alpha level of 0.05, our p-value of 0.141 is not less than that. So you can say that in words, or you can do what I did on the previous screen. You can show it like an inequality. So therefore, we do not have sufficient evidence to reject the null. Writing fast, I'll need to slow down to keep my cursor caught up. And conclude the percent of female participation is greater than 42%. So this piece right here, this is your null hypothesis. So you're either going to reject the null or fail to reject the null. So we don't ever accept the alternative. Don't say that. Just say we fail to reject or reject. Okay? And so that's our test. The next question says, was your test one tail upper, one tail lower, or two tail? Well, when you look at your alternative, we want it to be greater than 0.42. Well, that means it's a one tail test. That's why I always draw a sketch. And so remember, we were upper, or on the upper end of the normal curve. So we are one tail upper. Okay, and it says, explain why you choose that kind of test in this situation. The companies will change strategies only if there's strong evidence of an increase in female participation rate, as opposed to their current 0.42. So that's why we're choosing that alternative, because we want to possibly show that. Then the last question says, what does your p-value mean? Well, I got a couple of options that we can talk about. Remember, p-value is that area under the curve that we've shaded, that the area beyond the test statistic that we got. And so here's a couple of contextual ways we can say it. If the proportion or percent of female athletes has not increased, we can expect to find at least 202 females out of 454 pre-Olympic athletes about, and this is our p-value, 14.1% of the time. So this is just explaining how you can use your p-value. Remember, we calculated this little guy earlier. And just put in contextually, if the percent of female athletes has not increased, we can expect to find at least 202 females out of the 454. I can't read my writing. 454 pre-Olympic athletes, about 14.1% of the time. So this right here, this piece right here, is just saying has not increased. It's the null. This is just another way to say the null hypothesis right there. You might want to use this other option. So, oops, sorry about that. The high p-value indicated, because it was high, we didn't get to reject, indicated that these results could be reasonably explained by sampling error. So I fail to reject the null hypothesis. Okay? And so, in other words, our goal is to, when we do that research, we don't want our movement from the mean to be due to just sampling error. This word right here. We want it due to it being the null hypothesis isn't working. I know for sure, beyond a shadow of a doubt, that my experiment is more than 42%. And I have the proof to it. It's significant enough. Okay? And then I may have another version for you. With a p-value this high. See, I want it to be low, so I have to say it's high because I didn't get to reject. It is highly likely that the percent of female participation would be this, and in this case, high, because this is my alternative, because I want to be greater than what my null was. If the null were true, it is very likely that the observed results can be explained by sampling error. So, in other words, I'm going to get 44.5%. That's not that significant. So I'm off from 0.42 due to what we call sampling error. So I'm within my bounds of error, if you will. So hopefully that gives you something to grab onto. So any of those ways to explain it is appropriate. Hope I've helped.